So on your 18th birthday, you deposit 10,000, pays 5% annual interest, compounded continuously. How long will it be until you have 50,000? Okay. So which formula are we using? A equals PERT. All right, so we got A equals PERT. Now we got to put some numbers where they belong, because we know we got to solve for T. How long will it be? So we know we got to solve for T. So we got to get numbers for these letters. So what is going to be anything? What is A? The output 50,000. P is what? 10,000. E is E 2.71. R is what? 5%, which is what in decimal? 0.05. So good so far. We're trying to get that T by itself. We're going to solve for T. So divide by 10,000 here. So we got 10,000. Cancel that out. That's going to be 5. 5. So 5 is equal to e to the 0.05 t. So now what? How do I get the t by itself? How do we get the t by itself? How do we get the t by itself? Anybody? How do we get the t by itself? We're just gonna sit here and just. What do we get? How do we get the t by itself? So we don't know how to get the t by itself. All right, let's do this lesson, and maybe after the lesson we can learn how to get the t by itself. Let's go with transformation of log functions. Graph y equals 2 to the power of x. All right, let's go, because we're going to do 2 lessons today. Here we go, one more time. Here we go. Don't be looking at notes. Here we go. You're going to plug in x's, -3. Don't say anything. Becky, what's the output when you plug in x equals negative 3? Loud. Thank you. Or yes. All right. Good. Everybody, yes. Yes. 1/8. Quickly, Evelyn. Next one. 1/4. Andrea, when you plug in negative 1. Huh? What? 1/2. 1/2. 1/2. You plug in x equal to 0. Diego. That's the same one you had last time. Was it? When was the last time we asked what's 2 to the 0 power? Huh? You said 0. That says 1. Brian. And you guys say, well, why are you doing this again? 4, 8, and then it goes what? It goes up like that. It's like it goes like that, like that, like that, like a ramp, like a ramp. All right. So now, the reason why we couldn't figure that out is because like we don't know the inverse operation of what we had. So hopefully we do know how to solve something like what? 2x equal to 10? Or you can do mental math, no? 2 times 5 is 10, no? But what would be the step if you were going to do the whole thing, solving it? What do we do? What's the inverse operation of multiplication or multiplying? Divide by 2, yes or no? So we got what? Something x minus 5 equal 3 or something. What do we do to get x by itself? The opposite of negative 5 is positive 5 or whatever, no? So the problem we had in the warm-up is that we don't know what the inverse operation of a exponential function is. So how do we figure out what the inverse operation of it would be? Is to it's called inverse operation. Is that we switch. You guys remember when we did y equals f inverse of x? Remember? You remember that? We did f of x. Find the inverse function of f of x, which is f inverse of x. So how do we find the inverse of this function? Well, let's do it like this, like the easy way. Let's do it the easy way. Switch the x and the y. So we're going to put what? X is equal to 2 to the y power, basically. And we got our x and our y. And basically what are we going to do? Just everything that is output becomes input and input becomes output. Let's do that. Let's do it like that. Simple. So we don't even have to think too much. So if our input is 1/8, the output is negative 3. And all that. Let's go. Let's just continue on. And now we can plot these points. X is 1/8. X is 1/8. Y is negative 3. 1/4 is negative 2. 1/2 is negative 1. 1 is 0. X is 1. Y is 0. 2, 1. 4, 2. 8, I can't graph that. With respect to y equal to x, to y is equal to x, it's reflected, and you could see that that point lands on this, that on this and that. They're inverse functions of each other. So this right here is going to become a new function right here. This function, this right here is going to be. I don't know why they called it like that, but they just decided to call it like that. They decided to call it what? What do you think? What do you think they decided to call it? What do you think they decided to call this thing here? I think it's right here in the what is this in the lesson? In the lesson, what does it say? Transformation of what? This is going to be called a log function. So the inverse of this, of that y equals 2 to the power of x, is going to be called y equals log with the base. The base is this base 2. So I'm going to put a log with the base 2 of x. So y equals log base 2 of x is this function right here. Yep. That's it. We created a new function we needed. Log function is the inverse of an exponential function. So that's what we're going to study for the next week before winter break. All right. And we're going to go back to analyzing the exponential function a little more, and also analyzing the log function a little more now. Let's see. You guys got it? So we can move on. We can move on because we got 2 lessons to do today. Okay, so we gotta move on. You can go back, and I opened the lesson on the website. You can go back and write down anything you're missing, but we gotta continue. All right, here we go. So let's go ahead and copy that down, and we're gonna fill that out and figure out what is the name of the function. What is the vertical asymptote? What is the limit as x approaches negative infinity of the function? The horizontal asymptote, the x-intercept, y-intercept domain, and what is the limit as x approaches infinity for the function? All right. What's the name of this function? Man, if not everybody's just saying that once. Huh? All right, so what's the name of this function here? Linear. It's a linear function, no? What's the name of this function? Second degree, it's a quadratic function like that. What's the name of this function? What's the name of this function here? Yeah, let's go with, what's the name of this function here? What's the name of this function here? Absolute value function? Absolute value function, yes? What's the name of this function here? Oh, I didn't change colors. What's the name of this function here? Reciprocal function or what? Or you could also call it a what? Rational? It's the reciprocal function, rational function. So you really need to become familiar and know the names of these functions. So the name of this function, and I call it, it looks like a ramp, you know, because people that skate, they go on the ramp like that. It's an exponential function. It's going to be y equals, for the most, let's do it with the base 2 for this one, because that's what we've been doing. So it is an exponential function. Let's go ahead and write down y equals 2 to the power of x. That's specifically where base is 2. It doesn't have to be 2. It could be a base 10. It could be, you know, the base has to actually be greater than 0. It can't be negative. So if this is going to be exponential, this better be some kind of greater than 0 number. It can be a 0 and it cannot be a negative. Negative is, if you have it right in the front out here, that makes it reflect. So that base has to be positive. What's the vertical asymptote? Where's the vertical asymptote? Does it have a vertical asymptote? What is a vertical asymptote? Vertical asymptote is when you got something like this, no? And it's approaching some vertical asymptote like that, or something like that, no? Or going like that, approaching something, remember? So, no, it could never, well, definitely this thing is going to go forever to the left, forever shooting that way, forever that way, forever that. It's going to keep going. You say there's an asymptote here, it'll forever go, it has no vertical asymptote. It has no vertical asymptote. What's the limit as x approaches negative infinity of the function? It's okay to guess if you, or maybe you're like, I think this is the answer. Anybody? 0. Thank you. It is 0. So as I go to negative infinity, it'll continue trying to get to y equal to 0, but will never, ever cross it. So it looks like you're like, oh look, it's almost gonna. No, not even. No. It's not gonna cross it. So it has an asymptote right here. Oh yeah. So, meaning that the horizontal asymptote is what? What equal to 0? I said y equal to 0, no? Y equal to 0. What's the x-intercept? What? None, for what I just said for like 3 minutes already. You'll never get under the y, under the x-axis. You will never cross it. What's the y-intercept? 1. What is that domain? All real numbers? And what's the limit as x approaches infinity? Infinity, yeah. Infinity. Next, let's analyze the function we just came up with today. Let's analyze this function. and it's going. Just make a rough sketch of this graph, kind of like, don't take too long because we got to get going. Just draw something like that and do something going like that. Call it X, call it Y. That was so quick. I got done in 5 seconds. So you know this is going to be the, we're using log base 2, so we're going to call this function y equals log base 2. Am I using that? Let's see. Okay, so now, if we want to be exact, the inverse of the other one, then this would be a base 2 here. If we want to say that that graph is log base 2 of x. For any log function, they all log functions do look like this. They go like that. What's the vertical asymptote? Anybody? Is there a vertical asymptote? Yes. Where is it at? At where? X equal to 0, because it will never cross here. It will never cross here. So it's going to be at x equal to 0. Man, I'll give you extra credit if you can answer this question. What's the limit as x approaches negative infinity of f of x? What? Anybody? Who said it? Who wants to raise their hand? Extra credit. What do you think of that? Why? No, how can it be white for you? Anybody else? What's the limit as x approaches negative infinity? It does not exist. Because it's not even it doesn't even get a chance to go to negative infinity. Negative infinity is negative infinity. It just stops here, and it's just weird. This does not exist. The limit as x approaches negative infinity does not exist. What's the horizontal asymptote? None. It doesn't have any. X-intercept. 1. Y-intercept. None. What's the domain? All reals? Huh? All positive numbers? Is it all positive numbers? It's never going to cross again. Domain is where do you see this green graph I have? It will never, it's like wherever it wants to go to, it will never reach this left side of this dotted red line I have. So it's going to be forever that way. So not including 0 to infinity, or we can say x is what? Greater than what? 0. Not including 0. Because then if it's including 0, then it's saying that it will be, will equal to 0, which is not. So x greater than 0, no? So what is the limit as x approaches infinity? Huh? Infinity. Very slow, like extremely slow, but it will eventually reach infinity. It's trying to reach infinity. It will. Yep. Moving on. Okay. So now let's do these transformations of the log function. So this is the parent function we have here. So this is y equals log base 2 of x. And I'm just going to tell you that use this focal point right here because it crosses the x-intercept, and then you know how it goes. Then you can just draw it. It's a rough sketch of it, no? So now, what is adding 4 to it do to the adding it right here? What kind of transformation is it? What kind of shift? It's a shift. Left, right, up, down. Up what? Up 4. So what I'm gonna do is just I'm gonna grab this point 1, 2, 3, 4, and I just trying to like be as good of a drawer as it can be. So it's just a rough sketch. I don't know. I guess I'm just gonna go like this. It's going something like this. Okay, it's a rough sketch, and we're pretty much just draw a rough sketch. Make sure that it doesn't cross here, and that would be a rough sketch. It shifted up 4, so something like that. All right, messed up, but let's do problem number 2. These are rough sketches. So this one has a base 10. All right, I'm already going to tell you right now. When it's missing it's not because I forgot. It's, I guess, basically because I'm saying that this is a base 10. If it doesn't have anything, automatically it's a base 10. Shifted what? Up, down, left, right. Right, how many units? 2 units. So, again, you're just going to go get this focal point and move it to the right 2 units. And then draw a rough sketch of it, and we're moving on. Make sure that the 1 over to the left is not going to cross it. So you cannot cross here. You're going to go up like that. Something like that. Whatever. I mean, that's messed up. Anyways, it should be more like that, but yes, good enough, something like that. Because it's the bigger the base, I'll tell you already. The bigger the base, the quicker it goes like that. It goes down like that. So if this is 20, then it'll be the faster it goes like this. All right. Next. Okay. So this one has 3 transformations, and you'll never get it wrong if you go like you read a book from what to what, from left to right. Same thing here. If you do the transformations from left to right, you should be good to go. So what's the first transformation? Reflected about the what? X-axis. Yes, that's the one I messed up last time when I was trying to do it really fast at the end. It's about the x, and then what? Shifted to the right 2, and then up 3. So again, like I said, how would you be able to do this really quick? Look at the focal point. You could just kind of draw it. Do the first transformation. This is the way I'm going to do it right now. Like, just quickly, is that it's reflected, then therefore this got to go up, and then this one's going to go like this. Okay, that was the first transformation. The next one's got to move it up, up. No, okay, I got to go right too. If I'm going to go from left to right in doing these transformations, I should go to the right too. So I'm going to move it to the right too. So it's going to be something going like this, so I don't mess up, something like this. And then the last one is that I'm going to move it up 3. 1, 2, 3, and then you're not going to get it wrong. I mean, it's going to not be perfect, but you're not going to get it wrong. That should be good. So 1, 2, 3, and that should be good. Yep. Okay, so the sad, which one is the most famous irrational number? Pi is, yes. Yeah. And then the one that should be very famous and it's not is what? E. So E, hey, something that pi doesn't have, so he could be like, E is, now he's happy because it has its own inverse function. So the inverse of E is ln. So it has its own inverse. So shift it up 3 units, but it's treated just the same as a log function. But it's just that it's a little more special. The base of ln E is going to be 2.7. ln is going to be 2.71 or whatever. So anyway, so it looks something like that. And it's going to be shifted up 3 units. So move it up 3 units. So yeah, it's the same thing, the same as a log, except it's more special. It has its own. All right, enough of this. Let's go on to number 5. Okay, let's go. Let's go ahead and do. Now we can find powers. Exact powers for something that is not exact. You see, what you already know is this. No, I hope. What is 7 to the 1 power? And what is 7 to the 2nd power? 49. So you know that this number here, y, is between 1 and 2. Yes or no? So now the question is something between 1 and 2. How can we really get that number? What would be that number? Exactly. How are we going to do it? Change of base? Are we going to use the change of base? Yes, we are going to change the base. All right. So what we're going to do is this. We're going to do what you do to one side, you do to the other side. So let me leave some space. 7 to the y power equals 20. We're not going to divide. We're not going to add. Now we know that we can use what? A new function called log. And there's these properties. There's 3 properties that we're going to go over later. But I'm going to already tell you that there's this one weird property of logs is that you can bring it to the front. If you got this, you take a log of both sides of this. You can bring this to the front here. It's called the power property. And we'll go over it later. So we're going to go y times log base 7. Because I'm bringing this to the front. And it's going to equal to log 20. Now, how can I get the y by itself? What is the opposite of? Divide both sides by what? Log 7? Log 7. So now we got our y. So go ahead and get your calculators. Get your getting hot in here. Yeah, sure. No. Get your calculators so we're gonna do this. There's two different ways of doing this. I guess I don't know why this is the way I just did it. I don't know if it's the same as in PowerPoint. All right, we're gonna go ahead and do log 20 divided by log 7. So let's go ahead and do log. Where's the log function at? You see that second button and then right there's log. Go ahead and do log 20. Enter, get an answer. Divided by log of what? 7. Log 7. And what are you getting? What are you getting? About what? 1.5 what? Let's go with 1.5395. Let's stop there. 1.539. Now, go ahead and do this. Do 7 to the 1.5395 power. Go ahead and do 7 and do the little up on 1.579. A lot of you guys, I see you guys just sitting around. You better get going and learn how to use this, because I'm not going to help you when you take the test. What are you getting? 7 to that power, what are you getting? Is it about 49? Is it not?
No, it's supposed to be 20.
Oh, it's supposed to be 20. How did I do this though? The change of base formula. Log base b of m equals this. What? Okay. I'll give you a formula already. All right, let's use this formula here for doing logs. There's this change of base formula. Write it down. Let's just accept it that it's true. There's this change of base formula, and I can prove it later maybe as to why this is true. Log base b of m equals log base b, log base of m over log b. Basically, it goes like this. And why do you use this? Is because the calculator only knows a base 10. So whenever you have something that is not a base 10, we can change it to a base 10. This is a log base 3. So if we got log base 3 of 15, it will equal to, all right, here we go. Split the log, one on top, one at the bottom. One on top, one at the bottom. And put the big number on top and the small number at the bottom. It's getting too hot in here. All right, give me the number. Practice with the calculator. What is it? What's the answer? Just punch in log 15 over log 3. Right, what are you getting? Log 15 over log 3. Log 15 divided by log 3. Log 15 divided by log 3. Are you getting what? 2 point what? 464. So just practice one more time. Quickly, everybody, like this. Look up here. Look up here. Whenever you get something that is not a base 10, whenever you don't get something like log 35, because that's just log 35, you assume this 10 here. So whenever you have a number here that is not a 10 or is not there, then you automatically, to get the answer to this, all you're going to do, get a calculator and go what? Log 35, get an answer divided by log 4. You don't even need to write this down. Okay? You're going to go ahead and hit that. Log 35, get an answer divided by log 4. Let's go. Log 35 equal, enter, divided by log 4. What are you getting? Okay, so we're ready, I think, to do this now, to get the answer. get the answer to the original question. Let's go to number 7. Pick up. Did you leave some space? I should have told you to leave some space there. So on your 18th birthday, you deposit $10,000 in an account that pays 5% annual interest compounded continuously. How long will it be until you have 50,000? So it was something like 5 equals e to the power of 0.05t. Yes or no? And you say yes, and you say yes. So it's gonna let me leave some space. And now you're like, I'm enlightened now. I know that there's some other thing. So this is an exponential. What's that? Inverse operation of an exponential. What's the inverse operation? It's going to be a what? Some kind of what? Log. Yes or no? Log. But this particular one, e, he's happy. Now he's not sad because it has its own special inverse operation. And which one is that one? You guys are all saying what? Helen. Yes? So, there was that one thing I told you guys that there's a special property about this. What is that special property? The special property was that the power goes to the front here. So that's what I'm going to do. So whenever you take ln's, you can always bring this. See, that's the power. You're like, how do you bring this from the bottom down top? This thing is the one that gives. All right, let's go. ln5 equals 0.05 t times ln e. I guess we can divide both sides by. Okay, so now. You know what ln and e is going to be? Like they're inverses of each other. They undo each other. They undo each other and they become 1. This answer is 1. So basically this one, ln and e, cancels out. That just brings it, it's like disappears. It disappears and this comes down. Because ln e, okay, put that in a calculator. What's ln e giving you? Go ahead and put ln and put e. ln and put the letter e. ln and then where's the e at? And then hit second and hit e. E to the power 1. What's ln e to the power 1? What is it? It's 1. So they undo each other. Like it's like boom. And then it just become 1. Not disappear, but it becomes 1. They become 1. So this is gone because it's 1. So now how do we get the t by itself? So t is going to be approximately ln 5 divided by 0.05. ln 5 divided by 0.05. So about how long is it going to take for your money to go to 50,000? 32 years. Let me show you guys the other way of doing this. Hey, I already told you guys that we can go ahead and take an ln of both sides, or we can put it in. This is an exponential form here. Let's go. So if you have something like this, let's practice something more like this. 2 to the 3rd power is 8. Man, I guess let's go. It's 8. Would you agree that a is equal to 2 to the 3rd? Let's see. Go ahead and write that down. A equals is. Would you agree that that's a true statement? Do you agree that 8 is equal to 2 to the 3rd? What do you? Brian, don't be saying 6. So you do agree. So if you agree that this is a true statement, then let me just quickly show you another way. Maybe it's going to confuse. It shouldn't confuse you. The way we put this into log form, we go like this, and we're going to practice this more later. It's going to go like this, everybody. Log. Let's go. Log. What's the base? What's the base? Log base 2. We're going to practice it a lot more later. Log base 2 of, here we go, of what? Of 8 is equal to, and let's say that we didn't know. Let's say Brian is over there saying, I don't think it's, let's go, we don't know what that is. Let's say, we go like this, right? We say that we don't know. So go ahead and put that in the calculator. Go ahead and put log 8 divided by log 2. Go ahead and put log 8 divided by log 2. What are you getting? You're getting 3, no? So that's another way of doing this. Choose whichever one you like. I don't know. You can either take a log of both, ln of both sides, or you can go ahead and rewrite it in log form and use the change of base formula. And we're done with this first